We are going to practice solving equations with fractions and a strategy for solving them, getting rid of the fractions that we call fraction busters. All right, so here's our first equation. We have negative 3/5 x equals 2/3. So the first way that we can do this is just the same way that you would solve any other equation. I'm looking at this negative 3/5 x, and that negative 3/5 is multiplying by x. So to undo multiplying by x, I'm going to divide, or undo multiplying by negative 3/5, I'm going to divide by negative 3/5. This makes a 1. Negative 3/5 divided by negative 3/5 is 1, so 1x equals, and then 2/3 divided by negative 3/5. Well, I have a positive divided by a negative, so I already know that my answer is going to be negative. So now I can just look at the numbers. I have 2/3 divided by 3/5. If I remember back to division with fractions, I know that I keep, change, flip. And I get 10/9, which is the same as 1 and 1/9. 9 goes into 10 one time with 1/9 left over. So x is equal to 1 and 1/9. Now that's just one way to do that. I could also do fraction busters, this method. So what I do is I look at my denominators, and I know that I want to get rid of my denominators. I don't want to have fractions anymore. So I have one that has a denominator of 5, and I have one that has a denominator of 3. And what denominators really are just division. So in order to undo dividing by 5 and dividing by 3, I'm going to multiply by 5. But what I do to one side, I have to do to the other to keep the relationship the same. So I also need to multiply this side by 5. But I also have a denominator of 3, so I'm going to multiply each of these by 3 as well. And I like to put the over 1, that looks kind of goofy. I like to put the over 1 so I don't forget how to multiply with fractions correctly. Now, a lot of you may be looking at that and saying, well, 5 times 3 is really just 15, so couldn't I just multiply everything by 15? Sure you could, but then you would have to take some extra steps, because then you'd still have to do the division. When I'm looking at it this way, I can look at this first term right here, and I have, I'm going to rewrite it so you can see what it really looks like, negative 5 times 3 times 3 over 1 times 5. This is really x. This is really what all of this means, because it's all multiplication. So when I know I have this, I can look and say, oh, I have a 5 in my denominator and a 5 in the numerator, and 5 over 5 is really just equivalent to 1. So I don't need those 5s anymore. Those are gone because multiplying by 5 and dividing by 5 undo each other. So they really make 1. So what I'm left with is 3 times 3. So when I do this, I just like to cross those off. I'm left with 3 times 3x, or negative 3 times 3x, which would be negative 9x. And then I'm going to do the same thing over here, but this time my denominator is 3, and I have a 3 in my numerator over here. So what I'm really doing is 2 times 5, which is 10. Now I have these numbers right here. I have negative 9x equals 10. My fractions are completely gone, and I can just solve like I normally do. Dividing by negative 9, and I have x equals, well, negative, and then 9 goes into 10 one time with 1/9 left over. So I get the same answer no matter what I do. It just depends on how comfortable you are with your operations with fractions. Let's do one more example. This one right here. I have 1/3 x plus 1/4 x equals 4. Now, I noticed that both of these terms here have an x attached to it, so I need to add them together. But when I add fractions together, I have to have a common denominator. So right here, I'm stuck making a common denominator. So I need to find a common denominator for 4 and 3, and that would be 12. Now there are many others, but 12 is the smallest. So I'm using my giant one and rewriting those fractions so they have a denominator of 12. 3 times 4 is 12, 1 times 4 is 4. 4 times 3 is 12, 1 times 3 is 3. So I have 4/12 x plus 3/12 x equals 4. Okay, now I have these two that I can combine. So 4/12 and 3/12 is 7/12 x. I can only combine them because they're both x. Equals 4. Now I want to know what x is, not 7/12 x. So I need to divide both sides by 7/12. This makes a 1, so I'm left with x equals. And then I have 4 divided by 7/12. I'm going to do 4/1 divided by 7/12. So I remember to set up my fractions correctly. I keep, change, flip. And I get 48/7. 7 goes into 48 6 times. 6, that would be 42, and I would have 6/7 left over. Okay, so how to find my common denominators. Those are the steps if you're just going to solve it the regular way. If you're feeling comfortable with fractions, absolutely use that method. If you aren't feeling very comfortable with fractions and you would like to get rid of those fractions, here's what I would do. I'm going to actually just rewrite this really quickly right beneath it. I'm going to have 1/3 x. I'm giving myself just a little bit of room so that I can write next to it. Now, my denominators are 3 and 4, so I'm multiplying everything by 3 times 4/1 so that I can get rid of my denominators. I'm undoing the division that my denominators are doing. Now, I have to multiply every piece by 3 times 4/1, every term by 3 times 4/1, including this 4. This is really 4/1. So I can just multiply these by 3 times 4 since it doesn't have a denominator, just to keep it consistent, or just to keep it easier to think about. So now I'm going to go through. My first term is this piece right here, so I'm going to get rid of this 3 and this 3. I'm left with 4 times 1, which is 4x. My next term right here, I'm going to get rid of my 4 because I have a 4 in the numerator and a denominator. I'm left multiplying 1 times 3x, which would be 3x. And then is equal to, well, 4 times 3 is 12. 12 times 4 is 48. So now I solve. I have whole numbers, and now I can just do my steps like I normally do. 4x plus 3x is 7x. So 7x equals 48. I divide both sides by 7 to get 7 all alone, and I get x equals, 7 goes into 48 6 times, with 6/7 left over. So same answer as before. This time I just was able to get rid of my fractions. I didn't have to make a common denominator. So the choice is yours, whatever you feel most comfortable with.